Alright, starting Unit 8, which we're going to be talking about right triangles and trig. First thing we're going to look at is kind of review the Pythagorean Theorem. We've talked about this before. We've used it this year already. But there might be a few points that we're going to address today. You'll recall that the Pythagorean Theorem is the formula made up of the square of the legs, when you add them together. That's going to be equal to the hypotenuse squared. Now the hypotenuse, you'll recall, is the side opposite the 90-degree angle. And if you think about it this way, it's the side that does not touch the 90-degree angle. The legs make up the 90-degree angle. The hypotenuse does not. So looking at some examples, if we're missing one of the lengths, we have to figure out where the hypotenuse is. In this case it's x, so we've got x squared. And we square the legs and add them together. So 3 squared plus 3 squared is going to equal x squared. 9 plus 9, we get 18 equals x squared. Well, we solve for x by taking the square root of both sides, and that simplifies to 3 radical 2. That would be your answer. Okay, next triangle we have, this time 15 is my hypotenuse, so 9 squared plus x squared equals 15 squared. This gives us 81 plus x squared equals 225. Subtract 81 from both sides, and x squared equals 144. When we square root that, we find that 144 is a perfect square, and it is 12. Okay, now we've got a little bit of a bigger number here, but we're going to end up with 25 squared plus x squared, those are the two legs, 65 is the hypotenuse, equals 65 squared. 625 plus x squared equals 4,225. You're going to want to make sure you have a calculator when you're doing this. Subtract 625 from both sides, and x squared equals 3,600. Square root, when we do that, 3,600 is a perfect square, and it is 60. Okay, so that's how we find the missing side of a right triangle if we have two of the sides using the Pythagorean theorem. One thing we might have talked about is a Pythagorean triple. A triple is a group of numbers. Saves you, it's a shortcut. It allows you to find the missing side if you know two of the sides. They end up being whole numbers. This next table shows you in blue, this row right here are common triples. For instance, look at number 7. Number 7, if we had to solve for x, typically we would say x squared plus 8 squared is going to be equal to 17 squared, and then we solve for x. However, now that we know that it's a perfect triple, we can look to see if it is. Look at 17. 17 is the longest segment, which is the hypotenuse, and we have a leg of 8, and since that's the case, 15 has to be the value for x. Okay? That makes it easy. We didn't have to use the Pythagorean theorem. And if you memorize those triples, it makes it pretty easy. Now sometimes though, you'll see the numbers below down in this larger section. What this is just kind of it's a proportional right triangle that's proportional to these triples, to these common triples that we see here. For instance, you'll see this one, all it is we multiplied 3, 4, 5 times 2 to get 6, 8, 10. If you multiply it times 3, we would get 9, 12, 15. So any number, if we multiplied them times all 3 times the same number, those are all going to also be Pythagorean triples. So look at number 8. Here we have a hypotenuse which we don't know, so the longest segment is the number we don't know. I do know that the shortest is 24. What I do at this point, if I'm looking to see if it's a triple, I look for the shortest triple, 3. 3 goes into 24. 5 does not go into 24. 8 goes into 24, and 7 does not go into 24. So it's possible that it could be one of these triples or one of these. Well, then I'll go run it through the test. 24 is basically 3 times 8. So then I'll go to 45 and say, okay, is that 4 times 8? Well, 4 times 8 is 32, and that's not 45. So this is not going to be one of the perfect triples it's going to come from. I know that 24 times 3, or 8 times 3, and let me do this in green. 8 times 3 is 24. And if I multiply 15 times 3, that gives me 45. Which means to find the missing length, I'm going to multiply 17 times 3. And when I do that, I get 51 for that. Now, I know they gave you this, but it's hard to remember all of those numbers, those triples. If we remember these common ones that are highlighted in blue up here, we can use those to figure those out. Now look at number 9. That one's not on there. If we're using that one, look at 28. What numbers go into 28? If we're talking about the smallest side of the triangle, we would have 7 does, 8 does not, 5 does not, and 3 does not. So if it's going to be a perfect triple, it's going to have to be one of these. So 7 times 4 equals 28. So let's see if 24 times 4, yes, that equals 96. Which means we're going to multiply 25 times 4, which is easy to do in our head. X equals 100. Notice I didn't have to do the Pythagorean theorem. If we wanted to, if we forgot the perfect triple or couldn't identify it, all we would do is we'd say 28 squared plus 96 squared equals x squared, and then solve for x. Okay, now the converse of the Pythagorean theorem, we can use that to identify the type of triangle that we are working with. And let's look at this first, number 1. And I'll explain to you what those inequalities mean. We're going to say, well, 30 squared, I'm trying to prove whether or not if it's a right triangle or not. 30 squared plus 40 squared, and then we'll have the hypotenuse, the longest side is 50 squared. Well, we end up with 900 plus 1600, and 50 squared is 2500. When I add this side, I get 2500. If the hypotenuse is equal to a squared plus b, which they are here, then it is a right triangle. If a squared plus b squared does equal c squared, then it's a right triangle. So not only can we find the missing side, but we can identify and prove whether it's a right triangle or not. Now let's look at this one. 20 squared plus 30 squared, and you do know that I'm picking 40 squared as my hypotenuse because it's the longest, because the hypotenuse is always the longest. So 400 plus 900, which is 1300. And 40 squared is 1600. Notice the hypotenuse is larger than a squared plus b squared. And when that is the case, it's obtuse. And that's what these inequalities up here are saying. If the two are equal, it's a right triangle. If the hypotenuse is greater, which is what we just had, if the c squared is greater, it's obtuse. If it's less, then it's acute. So let's look at this one here. Look at another example. 18 squared plus 24 squared, and then we'll have 30 squared. Well, 18 squared is, check my notes, make it easier on myself. 324 plus 24 squared is 576. And then that's going to be, when I add that up, 900. And 30 squared is 900. They're equal. That means that this triangle is a right triangle when both sides are the same. Alright, number 4, a little easier number to work with. 6 squared plus 8 squared, and then we've got 9 squared. 36 plus 64, which is 100. And then we've got 9 squared, which is 81. Notice the hypotenuse squared is less than a squared plus b. It's going to be acute. That triangle is acute. Number 5, 6 squared plus 12 squared, and then we've got 18 squared. 6 squared is 36, 12 squared is 144. When I add those together, I get 180. 18 squared is 324. The hypotenuse is larger. It's an obtuse triangle. And the last one, 10 squared plus 15 squared, and we've got 20 squared, so 100 plus 225 is 325. 20 squared is 400. The hypotenuse is larger. It's obtuse. All right. Okay, that's all we have for the notes. Looking at the assignment, 1 through 4, what we just did, we're going to identify whether it's obtuse, acute, or right. Remember, if we're doing this, we're saying that 7 squared plus 7 squared, and then 130, square root of 130 squared. What happens when we square a radical? Well, the radical goes away. And we're left with 49 and 49, which is 98. Less than, so it's obtuse. When you put some of these in your calculators, be careful. When we're squaring this number, for example, in the calculator you have to input that as parentheses 2 radical 85, close the parentheses, and then hit the square button. Otherwise, if you don't put the parentheses, it's going to square only radical 85, and then whatever you get times 2, which is incorrect. Okay. 5, 6, 7, and 8, you can do that on the missing one using the Pythagorean Theorem. I don't think any of those are going to be triples, so you'll end up with a radical. Leave your answers in the simplest radical form. Number 9 is a tricky one, so we'll kind of look at that one. We've got TVs, and TVs are measured by diagonal length. And I've got a 42-inch TV, which when I measure it across diagonally is 42. So the hypotenuse is 42. Now, it also says that it's got a 4:3 ratio, which old TVs used to have a ratio of 4:3. Which, if we think about that diagonal, that's a perfect triple, isn't it? The hypotenuse would be 5. So this is going to be using that same ratio, but we don't know what we're multiplying 5 times to get to 42. So we're going to say 5x equals 42. We can figure out what that constant is, and we end up seeing that it is 8.4, which now means we can find the width and the height by multiplying 8.4 times 4, so 4 times 8.4, and then 3 times 8.4, and those will give you your width and your height. And I'll let you figure those out. Next page of word problems, this one, not terribly difficult, a little bit of information to think about. Don't just not do it because it looks confusing, it's really not too bad. The ladder length is 25 feet. It's 7 feet from the wall. So now this forms a right triangle. What is the height from the top of the ladder? Well, what we've got is a right triangle, and we're missing the height of that right triangle. Pythagorean theorem, or if you notice it to be a triple, you can solve that. Whatever x equals, that's your answer here. Now B addresses the issue of the ladder's falling down and it moves 2 feet per second. So if 4 seconds pass, how far away from the house did the ladder move? Well, it's already 7 feet, which we said here. In 1 second, it's going to be 2 feet further this way. 2 more seconds, 2 more feet. So in 4 seconds, we would say 4 times 2 is 8. It's 8 more feet away from the wall, which means the total length there is going to be 7 plus 8, 15. And you're left with a ladder that's looking like that. 25 is still the length of the hypotenuse, but you have 15. If you're looking for the height, you now would have a new x. I would call that y for your new triangle. And I'll draw it in purple so you know what I'm talking about. Okay, that's after 4 seconds have passed. The ladder's kind of moved. It's slipping away from the wall. And the last one says 8.5, so we're going to do the same thing. 8.5 times 2 is 17, which means it already was 7 feet away. So now this new triangle is 7 plus 17, which is going to be 24. And it's going to be up against the wall like that. It's still got a length of 25. What is, we'll say z right here, the height of that. So we got a really smaller triangle. Okay. The rest of these problems, really gonna have to think about them. 12, the tricky part on that one, I don't think it's how far apart are they, because we know that this one's 150 miles away from the point. This one is 200. Well, we just use Pythagorean Theorem to find out how far away they are from each other. It's the second question, part B, that gets tricky, because 10 minutes later, how far apart are they? Well, airplane 1 is traveling at 450 miles an hour, and 10 minutes is 1/6 of an hour, so we'd multiply that times 1/6, which ends up being 75 miles. So 10 minutes later, they're not traveling 150 miles, they're traveling 75 miles less than that. So 150 minus 75 would give us 75 miles. And then we'll take 1/6 of the other airplane 2 speed, which is 600 miles per hour, and that ends up being 100. So we're going to take 100 away from 200, leaving us with 100. Now how far apart are they? Well, we'll do Pythagorean Theorem to find that missing length right there. Okay, that leaves you with 3 word problems to do on your own. Think about them, at least attempt them. Most of them, all of them, you can do at least part of it. So, all right, that's it.